Let's look at how you can convert units and put that into an application. Here's an example. You are in the US and you have $100 with you, and now you have gone to Europe for your vacation, and there you have 100 euros. So the question is, how much money do you have? You can see that if you have $100 and you have 100 euros, you cannot add these two together to make 200 of anything. $200? No. 200 euros? No. So there needs to be another step between these additions to make this work. And so that step is that you either convert the euros into dollars or you convert dollars into euros. So the crux of this addition is that the units need to be the same for every term. So this is a different unit dollars, this is a different unit euros, so you cannot add these two quantities together as is. So now you need to convert from one to the other. So as of now, the making of this video, 1 euro equals 1.11 US dollar. So 100 euros would be equal to $111. So now you can replace this equation by $100 plus $111, and that makes 211 total dollars. So the total money you have is equivalent to $211, and you can do it the other way also. You can convert the dollars into euros and have the total amount in euros instead of dollars. So you should try that. So here's another example. You have to find out how many meters there are in a light year, and you're given that the speed of light is 3 times 10 to the 8 meters per second. So how do you start? Let's write it down step by step. 3 times 10 to the 8 meters per second. So now we need to get seconds. How many seconds in a minute? 60 seconds per minute. You have 60 minutes per hour. You have 24 hours in a day, and you have 365 days per year, and you want to find the distance traveled in 1 year, so you multiply this by 1 year, and notice that all these units cancel out. The year cancels out with year, the day cancels with day, hours go with hours, minute goes away with minutes, seconds out with seconds, and so what you're left with is meters. So the answer here would be 3 times 10 to the 8 times 60 times 60 times 24 times 365 meters. Alright, and this comes out to about 9.46 times 10 to the 15 meters. There you go. That's what one light year is. And all we did here was looked at the units and converted from light year to meters. Okay, so let's look at one final example. How many moles in 20 tons of carbon dioxide? And well, we don't know what moles are, but do we need to know? All we can use is units to find out the answer to this problem. So you're given that 1 mole of carbon dioxide is 44 grams, and so we have 20 tons of carbon dioxide. We want to find out how many moles in those 20 tons. So what we can do is convert the 44 grams into tons, or we can say how many grams in 20 tons. Alright, so we know that 1 ton is 1000 kilograms, and 1 kilogram is 10 to the 3 grams. So now 1 ton is 10 to the 3 times 10 to the 3 grams, which is 10 to the 6 grams. So now 20 tons is 2 times 10 to the 7 grams. So now we're looking at moles. We know that 44 grams corresponds to 1 mole, and here we have 2 times 10 to the 7 grams, and that corresponds to how many moles? Let's call this X, and this is basically a ratio. 44 grams divided by 2 times 10 to the 7 grams is equal to 1 mole divided by X moles. We will find that X is equal to 2 times 10 to the 7 grams times 1 mole divided by 44 grams, which comes out to 454545.4545 moles. So we need not know what mole is, we need not know anything else about this system. Simply using units, we can find out the answer to this problem. And now you can go one step further and find out how many molecules of carbon dioxide exist in these 20 tons of carbon dioxide. Alright, let's stop here. Thanks for listening.